So, the timer is on. We can start this episode of Ugrodje in our subsection or our special section of our show dedicated to English-speaking guests and English-speaking audiences. This branch of our episode is designed so that we can get the best experts in the field, and they still can be shared among our audience. So welcome to our episode.
Hey
today we have a very special guest with us, Mr. Gunnar Morling, and my host Andraž, Brodul, Brodnik, and myself, Oto. Today we're attending a Make It conference in Portorož, Slovenia. So this is a coastline of Slovenia that you might see behind us. And,
but sadly not listen to.
And when we were deciding the agenda for the Make It conference, we really wanted to have you on this conference as well.
Okay.
Because in a while, there was this excitement in Java world where people were trying to solve this really interesting challenge that you designed, and people have gone crazy about it.
Absolutely, yes.
I managed to meet a few of these crazy people that actually solved your challenge, and I hope that we'll talk about it.
Yes,
so,
absolutely.
Welcome to the show, and if you can introduce yourself to the audience, that would be great.
Yes, of course. So thank you so much for having me. Really excited to be here. Really excited to be at the conference. And yes, so my name is Gunnar Morling. I work as a software engineer at a company called Decodable. We built a managed platform for stream processing there. And yes, this challenge, the 1 billion row challenge, actually was like a side thing which I started, after Christmas, and it ran for January. It really took off. Thankfully, Decodable also sponsored it in the end. But yeah, so that's the story.
Sweet and short. I would like you to tell us, what is the definition of what's the challenge about?
Right.
Let's go directly to it.
Absolutely.
What's it all about?
Right. Yeah, I mean, it's pretty much in the name there already, right? So it was a challenge, and the task was to process a file which has 1 billion rows of temperature measurements. So it's essentially like a simple CSV file. Well, not quite, because the delimiter is not a semicolon, not a comma, but it's a semicolon. But it's like a CSV file, and there's essentially rows of temperature measurements. There's a station name like Hamburg or Portorož, and then a values associated to that. And the task was very simple. You needed to calculate the min value, the max value, and the average value per station. And the only caveat was, well, as the challenge name says, it's like 1 billion rows, which means with this file, a bit depending on the names and how long they are, it was about like 13 gigabytes of size, and you had to process that file as fast as possible. So very simple task, I would say, very simple to explain.
Very simple to explain.
And still people spend like 1 month, and I guess hadn't we, cut it off on January 21st, people would still be working on it probably.
I like that. I like that there was a deadline to it.
Yes,
it's not open anymore.
Yeah,
but
you just had to put an end to the madness at some point.
We'll go deeper, but just like for people that listen to this, try it out. It's still a really lovely challenge. Although you cannot submit your solution at the moment,
you still can
challenge yourself.
Absolutely right. And you can go there. I mean, all the implementations are there, so you can check them out. But I also would recommend people, try it out first by yourself without looking at what others did, to get some ideas. Then, of course, take inspiration. So this was part also of the challenge to, so people shouldn't work on it like secretly and not see what others do, but they could take inspiration and be inspired and learn from what others did.
Yeah. I meet a lot of people in December where there's this Advent of Code challenge, right? And it's Christmas themed, but look, you don't need to grind every day for to solve all the stars, to all the challenges, but you can learn also through the year.
Right.
With the challenges given, just explore what other people do, and I think that's a really important point. It's not like, if you don't have children or a lot of free time, then you can do it in a specific time frame, but like you can learn your whole life,
yes,
right?
Absolutely, yes. And I mean, I was thinking to do it during Advent of Code, but I decided against it because I felt
that would be too much for
people.
people.
It would be too much, exactly. And also, it would just be nice. I mean, January typically is a bit slow, and maybe people are looking for something interesting to do. And also, I just had some time myself after Christmas to, define the challenge, and that's why I said, okay, let's do it during January and see what people do with it.
I want to go now talk a bit about rules.
Right.
You wrote these rules, and first rule, and there might be more. I think I wrote out 3 of them, but there might be a few very technical details. First one is no external libraries.
Yes, exactly.
Why is that?
Mostly, well, for 2 reasons really. So the goal of that was, to, provide people, and also myself, frankly speaking, with the means to learn something new and find out about new APIs in Java, the new possibilities like foreign memory and foreign function API, vector API. So learn about those things. And if you were just to use an external library, I mean, there would not be that much learning, I guess. I mean, you would learn about that library maybe, but I think, it makes more sense to do it yourself and really dig into that and finding out about all the possible optimizations. So that was the one reason. And then the other reason, just for me, I wanted to, keep things manageable in terms of evaluating this. And so I felt, okay, if it's just like a thing, so this was another precondition, a single source file, so I can look at it, the entire code is there, so nobody is running their Bitcoin miner in a library on my environment. So this also was a reason to do that.
And one rule perhaps that kind of stands out, I guess, a bit is this: it needs to be done in application time. So nothing extreme in compilation time or anything like that. So everything needs to happen in runtime and runtime only, right?
Yes, right. So, and this was there because, I mean, how would you draw the line otherwise, right? Because let's say, then I could just go solve the task once, store the result in a file, and then my actual measured run would just load that file and print out the numbers from that. That would be kind of pointless, right? That's why I said you cannot keep state. It needs all to happen at runtime, and that's what it was.
And we're still talking a bit about rules. You can get the sample data, you can generate the sample data, but in the test runs or benchmarking runs that you actually do they run on the same sample data, or how does the sampling of the data work?
Right. So this is actually a very interesting question because people did something which I did not expect, which just goes to show my own naivete when it comes to that. But so yes, I had this data generator, and this was there for practical reasons because I felt I cannot distribute a 30 gigabytes file.
Yeah.
I mean, I guess I could have done a bit or whatever, but so I thought, okay, people should just generate themselves, and then I don't have this distribution problem. Now the challenge was that this used a very specific key set. So I went to Wikipedia, I dug out 400 something different weather station names and the average temperature which actually exists at this location, and then the generator would create a normal distribution of random values.
You did actually put more effort into
so
making it realistic.
Exactly, so it's somewhat realistic. And now people optimized a lot for that specific key set. So they and I assumed, okay, those are just examples. You shouldn't make any assumptions about the station names. But people optimized a lot by choosing specific hash functions which are collision free for those 430 names and this kind of stuff. So which is then in the end we had another evaluation where we actually ran against 10k different stations, also longer names and so on. And then actually the leaderboard also was a bit looking different between those guys who very much optimized for the specific key set. Versus those guys who tried to solve it in a generic way as good as possible.
And then there are a bit, these are rules, but then there you have a few hints in there. So it's UTF-8 and there's only 10,000 cities.
Right. So
there are
right, and people asked for that. So to be honest, this didn't exist initially. I wasn't really thinking that much, but then people asked, so yes, how many stations can there be? Because they wanted to know how large
the table is,
the table be and stuff like that. How long can those names be? What's very specific questions around encoding and so on. And then I tried to put some rules into place, and the challenge then was, of course, people had already submitted entries at this point, and so I also didn't want to create a frustration for those who already had entered, like by invalidating them. So it was a bit of a balance to, yes, okay, we want to make it more specific without invalidating existing entries too much. I mean, there was a little bit of that.
Yeah,
but
you're kind of like
exactly.
You're modeling rules a bit.
It was a bit like building out the plain value already offline.
Yeah, common problems when inventing a new sport. What about AO? So the disk performance and stuff like that.
Yes, so I/O, right? So,
yes.
I/O,
sorry.
Yes, so this is very purposefully not part of the challenge. So the way it is designed is, so initially I said, okay, I want to do like 5 runs of each entry, and I will discard the slowest and the fastest run, and I will then, from the remaining 3 runs, the mean time, that's the measured time. And the idea is that the slowest run would load the file into the page cache of the machine, and from there it's always served from RAM, so that I/O isn't part of the equation. And later on I actually made it even more explicit, and I just retrieved the file from a RAM disk. So it's always guaranteed to come from memory. The reason being, I just felt, okay, I/O is harder to measure, and I also wanted to be this CPU bound problem, and people should spend their time to CPU optimize and not the I/O path. But maybe there could be a challenge also geared towards that. But then I think it's also a bit more complex to run. So that's why I decided against it this time.
Probably there is a problem with controlling the environment. Had you had any problems with that?
Yes, funny you should ask. I certainly did. So what happened is I was trying to be cheap because I paid initially for it out of my own pocket. So what I ended up doing is I got a virtual environment on Hetzner Cloud. It's a German cloud provider, like really, fairly priced. And I thought, okay, I want to have exclusive CPU cores, right? I don't want to have noisy neighbor issues and competing workloads. So let me do dedicated CPU cores. But then I should be fine with this virtual environment. Also, I thought, because what happened is, at some point, I woke up the next day, 40 more PRs or whatever, waiting for review. And I ran the evaluation scripts, and I realized, all those times are off. Everything is suddenly twice as fast as before. So I ran an existing entry, and it was running in half of the time. And I was going, what's going on? What's happening here? And actually, I filed even a support ticket with them. And they told me, so they moved this workload to a different host. So even with my dedicated cores, they were just better cores, from one day to another. And then all my measurements were off, and I had to redo it. And at that point, I decided, okay, I need to get a dedicated box, which I really manage, or which I can manage together with the community, so nothing can happen to that. So that's what we did, and of course it was a bit of a challenge to just get it. It's more expensive, of course. Thankfully, Decodable helped to sponsor it, and then also I just needed to get help with managing it because, for instance, I wanted to turn off the turbo boost. I wanted to disable hyper-threading to make it more comparable, and people from the community came and helped with that. So at some point I asked on Twitter, so hey, is there anybody who can help me with that? And René, who I didn't know before, he reached out and he said, yeah, I can help you. So we made a phone call, and I told about the things I needed to get done, and he was saying, yeah, I can do all that. And so he sent me his SSH key. I uploaded his SSH key to the environment. We had never met before, so I gave him the key to the kingdom, and he just did the right thing, and it was just great to see how it can work with the community.
Can you tell us a bit more about how you evaluate these things? Do you run them sequentially, daily,
Yeah.
Or
so what happened is I ran them when a new entry came in, or when an entry was updated.
Okay.
So they would do a GitHub pull request.
Okay.
And at this point in time, I would create run this entry.
Okay.
And I had some shell scripting for that, which made sure that the environment is configured correctly, which made sure the correct number of CPU cores is used, which ran the test suite which we had at some point. So it was invoking a single shell script, which again folks from the community built to make this as easy as possible.
Are you using any kind of benchmarking tools, or is just start time, end time?
No, there was a benchmarking tool, and now I'm blanking on the name. I really should know. but
It's like a Java specific.
No, a generic Linux tool for just like running, process a couple of times, and then calculating like the average value and stuff.
Okay. I got some technical hints, but I'm not sure what he wants to tell me. When you are...
I think it was like, can you please not touch microphone like you are doing it right now?
The
I think it's that.
Don't do that.
Yeah.
The problem is that it's sliding slightly. Okay. I would like to move, like from benchmarking perspective, like if you should like reevaluate all the solutions or only by submissions, like if you change the underlying system that runs it, like is there a time when you rerun all of them, or like you do nightly runs or things like that? Or?
Right, so I could do that. So actually the scripting infrastructure allowed to rerun any number of entries or all of them if I wanted to. And I did it typically, so the thing is initially I wasn't really interested that much in this leaderboard and like who is the fastest. For me it was more, hey, let's learn about this stuff and find out something. But then people I want to be the fastest one, right? So they care a lot about the leaderboard, and so that's why at some point I reran, let's say, the top 25 entries or so with different configurations. For instance, I wanted to run with all the 32 CPU cores with hyper-threading and so on. So I did that at some point, and then the scripting allowed to rerun those 25 or whatever entries with a specific configuration.
Would really love to now jump more to submissions.
Yes.
Can we do that?
Sure.
So obviously when I explained first time this challenge to Andraž, he said, well,
The funny part was like, I'm doing that for a customer with AUK, actually.
Okay.
Well, it's not the same. I think there is a bit of a less of data.
Explain the customer case, perhaps, just so we have like a...
We get all the permits from the US, building permits, because they're public data. And then, of course, you get that raw data and you need to normalize it. And the catch is we do not seek for sub 1 minute, whatever.
Right.
It just needs to be relatively simple to understand for a senior. We don't want to write, so every line of custom code or regex that I write or whatever complicated, it's not a benefit, it's a curse, right?
Liability, yeah.
Yeah, and so I wasn't the author of the solution. There was a funny detail, which is you just basically install AUK in a Docker container, and then I think it was like not that complicated code. It's something similar. We split the different states, and I do it that way, and it runs. I don't know. I don't know the data set. It changes, of course, all the time. Maybe it runs half an hour, but it's okay. It's streaming, right? Because Unix pipelines are basically streams. There's a funny detail. It stopped working when I was moving that to another environment because I was using the colleague who wrote it was using GNU AUK, of course, M AUK, or I don't know what the default installation on a different system was not working with a silent error, like exiting with 0, not outputting anything. When I heard of this challenge, I was like, because I understand, you have this challenge. The catch is to learn something new, to optimize really fast. But I usually look at problems. I'm like, okay, I have this challenge. How can I make it so people will understand it for the next 10 years,
yes, totally. No, absolutely. And what I observed there in the challenge is, I did a very simple baseline implementation, and this one ran like in approximately 5 minutes. Pretty canonical Java code, I would say. And then like improving over that by 1 order of magnitude, so taking it to 20 or 30 seconds, you can do this quite easily, and the code will be still very well readable. So it's code I would write, like average Java programmer would write, and it's easy to understand, easy to maintain. But then if you want to go another order of magnitude, so you want to go down to like 1.5 seconds, like top of the leaderboard. Then it's getting like really crazy, and this is like super dense code. You need like 3 lines of comments for each line of code to make sense out of it. And I would recommend people to go there like in their usual day job, I guess.
I want to slow you down just a bit
right,
there.
Okay.
I broke this down to like 3 levels.
Okay.
So if yeah, let's take it slowly because we want to go deep on these details. Level 1 would, let's say, be a aux solution.
Right.
Or in your case, baseline. You're a Java professional, so obviously 5 minutes. That's kind of like 5 minutes, 10 minutes is like average, or perhaps more senior engineer would take it like that, or do an aux solution. And that's, we said, 12 or 13 gigabytes of file, billion rows is to process. And that's like a baseline. How far on the like list of top submissions would that get you? Would that get you in the top 25 even, or?
No, as is today, no. You would be very much at the end.
At the end of
it, sort of solution.
Okay.
Right. So, I don't know. To be at the top 20 or so, or maybe top 30, would have to be below 10 seconds. Something
below
like
10
that.
seconds.
Yes.
Okay.
Yes.
Okay. We spoke in this conference with 3 engineers that did take the
nice.
challenge. We spoke with 2 senior engineers. Best times we have is around a minute.
Okay.
And 74 seconds. So these are like Slovenian times.
Okay. Yeah, no, it's good.
It's impressive.
I mean, my own implementation was like 5 minutes. I'm at the end of the leaderboard. I'm always the slowest one.
And both of these solutions that are like still very good in the leaderboards. Both of these solutions are, as you said, readable.
Right.
So people can understand them. They're like still single file, standard APIs. You can maintain them,
right.
and it's good modern Java code. I think it uses GraalVM as well in both
right.
cases, but it's cool. So if you write like that, you're good.
Yeah, totally. It totally depends on what you want to do, right? So if you need to run this like once per week or whatever, it's perfectly fine. If you want to win a coffee mug in a challenge, you probably need to do some more effort.
Okay, but now let's go to level below.
Right.
Okay, we also spoke with Peter Levard. He's a Slovenian guy.
Okay.
He's the best Slovenian guy.
Oh, nice.
His time is 4 seconds and 209 milliseconds.
That's really good.
And yesterday we had a pleasure of talking to him, and he guided us through the whole solution
right.
that he wrote. I will not pretend that I understand all of it.
It's really dense code. So for 4 seconds, it has to be like really tough.
What was really surprising was that he aimed to build a solution of his, and I'll link all this stuff there below. He tried to aim to not use unsafe, so he still uses Java APIs. But we can perhaps break down his solution just a bit, or at least what I caught, but you can expand it. So first thing is like memory mapping.
Right.
That's something that I think it gets common when you go below these numbers. And the idea there is that you read a file and you map it into a memory.
Right.
And then you start walking around.
Right.
What's the idea there? Can you tell us a bit more about that?
So, I mean, what pretty much most people did at the top of the leaderboard was, to memory map the file, and it will be mapped into off-heap memory, which means that there is no garbage collection interfering with that. You are just in control of managing that by yourself. There's a new Java API, the foreign function and memory API, which people used, which allows it, amongst other things, to map this entire 13 gig file into one memory segment. So before you also could do memory mapped files with Java, but you were limited to 2 gigabytes with the direct byte buffer in the past. And nowadays you can, map the entire thing all at once, no garbage collection, and that's what people did.
From which version of Java do you get these things?
I'm not sure when it got promoted to stable, but recently, maybe like 20 or 21, it got promoted out of incubator into the stable one.
we also met the vector APIs here at this stage, right?
Right.
Can you tell us a bit more what that is?
Right.
So it's not to be confused with collections.
Oh yes, no, exactly. Yes, it's not about the old vectors. No, totally.
Yeah.
And this actually was one of the things I was really hoping that people would use, because personally I'm just super interested in it, and people did use it. Yes. So the idea there is that your CPUs, they have extensions to their instruction sets, which allow to apply the same operation to multiple operands at once. So you can do the same thing for multiple values in parallel. And if you apply the same operation, like a comparison or whatever, to 8 operands at once, this might be 8 times faster in theory. And this is called a SIMD, so single instruction multiple data. And so things like Intel CPUs, they have AVX2 and AVX512 instruction set extensions, which provide a wide range of those vectorized operations. And the thing is, in Java, until recently, you couldn't really use those extensions, not directly as a Java developer. So the Java compiler would auto-vectorize code in specific situations. If it, you had like a loop and the compiler would detect specific patterns, then it might be able to emit vectorized code which make use of those SIMD instructions. But you as an application developer, you couldn't use that. And this is changing now with this vector API, and it's still in incubating state. I think like the 8th or 9th incubating release. So it's baking for some time, but you can use it already as a preview feature. And the interesting thing there is you can now do those things. You can say, okay, I want to look for a line ending byte in 8 or 16 bytes at once. And the nice thing about this is a Java API, so it's portable, because with other languages, let's say Rust or C, you also can use those instructions, but you would go down essentially to assembly level, and you would be specific to the architecture you're running on, and your program wouldn't be portable. Whereas with the Java API, it actually is portable, because the JVM takes care of compiling this to Intel instructions or Neon instructions on ARM. And now I feel like we as Java developers actually are at an advantage, because we can use vectorized APIs and still we are portable across platforms.
Beautiful.
Would you say that that's like readable?
Yeah, I think it's
like for the level of
right. I mean, you need to get a little bit the hang of it, right? To understand, okay, I want to work on multiple elements of an array at the same time. Then there's also this thing like you always have like a remainder of your data. So let's say, for the sake of the example, you work on an array which is like 20 bytes long, and you can process 8 bytes with vectorized instructions. So you can do this twice, like first 8, second 8, and then you have like 4 bytes left. And then you typically have to do this like in a scalar way, for the remainder. So there's, things you need to understand and make you like learn about. But overall, I feel it's code which still is fairly readable.
Yeah,
yes.
Awesome.
The other thing next to memory mapping vectorization is usage of parallelism. So parallelize as much of computation as possible.
Right.
That is also plays a big role in this optimization. At least that's my impression.
Yes, absolutely. So you want to make use of all the CPU resources you have, and so coming back to like readable and maintainable solutions. If you use the Java Streams API, it could be as simple as adding a parallel method call, like, calling this method parallel, and it would be parallelized to those 8 cores and gives you a nice speed up. But what's happening there is, so the computation would be happening in parallel, but reading the file, that would still be a sequential thing. And this is where it goes back then to the memory map file. So this is something which you need to parallelize yourselves by using like threads and, making sure you process different chunks of that memory segment with different threads. And people absolutely did this.
I think that, you mentioned this from your talk, that your baseline, you can correct me this, your baseline was 5 minutes, but with usage of parallel APIs, you managed to get down to 1 minute with it? Or
yeah, so it gets, I forgot the exact numbers, but it gets like 4 times faster. It doesn't get 8 times faster because the file reading is not parallelized that way. But still, it's a nice payout for like a simple method call, right?
Yeah, it's amazing. You basically added just like a dot parallel.
Exactly.
That was it, and implicitly it is kind of a map reduce, kind of
Yeah.
like vaguely, and it's like an insane boost.
Yes,
if
yes,
you
exactly. So
if you would
good-
compare maybe with other languages, then it would be much more trickier.
Right, yeah. So good value for the money,
Yep.
as to say.
Before we jump more into like unsafe world,
Oh, yeah.
I do want to mention hacks, and like one of the hacks that I'm calling it hacks, but or clever approaches to
Right.
solving this thing was like one was where you mentioned that you took names and people considered the collision like keys, etc. One thing that I think was also in Levard's solution was that taking the names of cities was not like very efficient.
Right.
So he got smart, for example, and he just took like a first character of the name and last character of the name and used that as a key because, for example, he found that that's going to consume less memory, it's going to be faster, and it's still kind of like less collision.
Yeah.
So people find like these insane optimizations of some
Right.
kind.
And then there's, of course, the risk that you make assumptions about the specific key set, right? So
Yeah.
this might be fine for a specific key set, but a solution was considered only valid if it worked for all possible keys. So
Yeah.
doing something like that, you would still have to do like the fallback to comparing the full name. If there's equality
Yeah.
in the short version.
Yeah, I see. Like,
Right.
I'm not sure how like these are like extreme optimizations to a degree. So like changing the file format, obviously all the stuff you wouldn't benefit through it. Changing the values too much, like all these things. Probably the solutions are not that generic.
It's like small cheating is like not implementing the whole hash mapping inside of it, but
Yeah.
like doing.
Right. I mean, so many people did custom hash maps,
Yeah.
or custom maps, I should say. And so what happens there is essentially you store the values in an array. You take the hash code of the key to
Yeah.
find the index in the array, and then of course you need to handle collisions. So
Yeah.
you need to, if you go to this array bucket or to this element, and there's a value there already, you need to compare. The name, is this the bucket I want to add to or not? And if it's not, you want to go to the next free slot in the array. And this created a bit of a nightmare for myself because you cannot test for that in an automated way. You cannot prove the absence of hash collisions in a test because people could use arbitrary hash functions, arbitrary seed values. So I always had to review for that, and it was like quite a bit of effort to understand. So actually, in the pull request template at some point, I made a comment. So if you have custom hash map implementations, point me to the place where you deal with collisions, so that I could understand about it.
I wonder if you would have like a team that would help you, and you could delegate it, and then like have a pre-review.
Right. Yeah.
But I was thinking like, would that even help you, or it would just like taint your view on the code, if you know what I mean? Because
Yeah,
then it's tricky. You may skip something else.
Right. Yeah. That's a good question. I didn't think about it. But I mean, actually, people helped a lot already. So people built this test suite, which we had initially. I didn't have any tests. I wasn't really thinking of that. But people built this TZK, test compatibility kit, which you had to pass. People did that. They helped with the environment, as I mentioned. They helped with just all the infrastructure for evaluation. So there was a guy, James Nochlin, who wrote like amazing shell scripts for making sure the environment is configured correctly, and then for running the benchmarks and with like colored outputs. So for me, it was just like a lesson. How do you write excellent shell scripts? So this was a nice takeaway for me.
Before I ask you how to go below, to get to the top or to below 2 seconds, I think that this challenge, I'm not sure if you published it on Hacker News or it somehow got into Hacker News.
Right.
What did that thing did to this challenger?
Oh yeah, no, actually, so, it could have been that I put it there, but somebody else also put it there. But yes, so at some point it was actually on first place on Hacker News, which was
beautiful.
Great.
Congratulations!
Yes. Thank you. First time that I had that, and it definitely helped with popularity. More people learned about it, more people contribute, and then of course you also have like the typical Hacker News guy, right, commenting there. And there was like the one comment. Actually, I had it in the keynote early this morning. Even how hard? This is not a hard problem. It's a trivial problem. Like everybody who can program a little bit, they can solve this in like half an hour. And then sure, like guys like Thomas Wirtinger and Alexei Shipilev and Cliff Click and all the other big hitters, they spent like an entire month optimizing this, right? And like going down to the instruction level. And then you have like the Hacker News guy. No, how hard can it be? I do it in like in 30 minutes. It's always like that, but it's funny.
Again, it gets on the surface it looks easy, which is for such a challenge it's really nice because it appeals to people.
Right, you can explain it easily.
Easily explain. Rules are simple.
Right.
Data is there. Results are. You either have the results or you don't. So it's like indisputable.
Yes.
It's challenging. I love it.
Right. And I also think this will be the biggest challenge next year if you wanted to do it again, to find another problem which is like that. So you can explain it easily, and still it has lots of potential, because I think you could find things which are also very tough and which give you enough substance to work on for an entire month, but it would also take you half an hour to explain it, and that would make it, I think, much less appealing, as you say.
From the outside world, like people ask, why would you do this stuff? And I keep telling them like that's completely wrong question. That's you should never ask
right?
that.
Yeah, because we can, right?
Not because you can, but equal, like you wouldn't understand the answer to that question even if I provided one.
To be honest, like I think that this challenge is one of super useful. Like it's pretty commonly that you get like large files of text that you need to do some transformation on them and then maybe save them as a per K file or whatever. So I think that this one is really realistic, especially now in these golden data science, AI learning days. And I think that this one is really the most applicable I've seen so far, if you ask me.
Yeah, and I mean, it has been in my mind for a while to do something with 1 billion rows. And then at some point I thought, okay, let's do it. And I think it's particularly interesting, of course, if you work on tooling around that, right? So if you work to create a database or work on tools like org, I guess, then of course you would apply all those techniques.
Okay, question: how do you go below 2 seconds?
I
mean, perhaps like if not a Java developer, Java has this kind of like, I don't want to say bad reputation, but like people say, it's not performant anymore. It's not suitable because of the garbage collection, and you should just use Rust and things will be magical, right? But like the leaderboard speaks for itself.
Right.
So, I mean, obviously the top implementation there are crazy optimized. People do insane stuff, but like these times are still acceptable, reasonable for the given channel. So Java is still very, very much relevant in this space, even in big data, machine learning, all these things, it's there.
And this was also exactly one of the things which I wanted to get out of this challenge, to make this case and to help debunk this misconception. And I think people definitely learned about it. Okay,
so my understanding of what it takes to go under 2 seconds, I'll try to summarize it, but you'll expand this.
Let's see.
Okay, so different distributions of JVM, that kind of helps. With GraalVM, we get this ability to do the more binary way of things, compile stuff into binary, run that.
Exactly,
I think that is kind of like where a lot of these solutions build upon that. You want to expand that, perhaps?
Yes, I mean, a few thoughts on GraalVM. So first of all, I mean, it also can be used as a JIT compiler, just-in-time compiler, right? As a replacement of the C2 compiler in your JVM. And even doing that, actually for this particular workload gave a nice improvement of a few percent. And this is, I think, also an interesting takeaway. Just try GraalVM as your JVM, not thinking about native compilation or whatever. It might give you an improvement in terms of throughput and latency, essentially for free, right? So that's one thing. But then, yes, of course, people like GraalVM also because it does the ahead of time compilation. And now I did not expect the times to go into that low range where this would make a difference. But actually people ended up going there, right? And because now what happens is all the compilation happens, at build time. So we don't have the just-in-time compiler. There's no interpreted phase. The compiler doesn't need to warm up, all this kind of stuff, which means we have like peak performance right early on, and your process is to start up faster. And now, well, if you look at those times, like 1.5 seconds at the top of the leaderboard, if you are faster to start up by 200 milliseconds, that's a significant difference in that range, right? And that's why, yes, people at the very top of the leaderboard, they decided to use GraalVM native binaries, which for me made life actually a bit harder because the compilation takes a little bit longer. So whenever I ran those entries, then I had to spend some more time for building those binaries.
But even like in production setups, if you do ahead of time compilation, you're willing to sacrifice more time in the build time because you get speed up in the runtime, right? Okay, that's one. And then the unsafe world. Right. That's a big thing.
Right. There's unsafe. Yes, exactly. So essentially, it bypasses all those boundary checks, and it allows you to directly work on this memory data. So it's again a bit faster. Also, of course, unsafe, literally. So I remember Roy van Rijn, one of the top contenders, when he played around with unsafe. He did it wrong. I mean, you get stuff wrong, right? It's just natural. And then, well, in that case, the JVM just crashes. And so he shared a screenshot of his like 30 JVM crash logs. So, it's a bit more frustrating, I guess, in terms of a developer experience to do that. But yes, so that's one thing. What I also found interesting, you can disable garbage collection altogether if you implement it the right way. Because if you don't allocate any objects in like your inner processing loop, you don't need garbage collection, which means you can, spend those CPU cycles then for working on your actual computations. And again, it's just a bit faster. So that's what some people did. And I think that's also very applicable to other problems. So let's say you were to use Java for, let's say, a CLI tool, a very short-lived process. Maybe you just can disable a garbage collection altogether and it will be a bit faster.
Well, one thing there is that my understanding was that top solutions also don't use a lot of objects as well. They try to use as little objects as possible and try to optimize that as well. And that's my understanding.
Yes, absolutely. So, they would work with the byte arrays directly, or maybe making a string object point to a specific section of the memory segment. Yes, all that to avoid allocating objects as much as possible.
One thing that I also learned by talking to Levert and his 4-second solution, that he spent a lot of time running the compilation with some additional flags, so that he actually sees a lot of how the compilation happens, how the inlining happens, all that. That is also kind of like what helps you.
Yes,
in a way.
I think it can make a difference at the very top. So I remember Thomas Würtinger, he specified lots of compiler flags and options to get out like the last few percents. I suppose it's something which you do like really at the end, once you have sorted out all the other stuff, you have done all your profiling and you avoid all the unnecessary allocations and whatnot. Then I guess you can get like the last little bit with those kinds of things.
It's trying to see how a compiler actually gets stuff.
Yes. And also it's getting then machine specific, right? So this also was very interesting. So Roy, at some point, so he was working on his ARM MacBook, like M1 MacBook, and the evaluation machine was an Intel AMD EPYC server. And now he got to a point where he did optimizations, so it was faster on his local laptop, but he submitted it, then it was actually slower on the evaluation machine because, I don't know, it had different length of SIMD instruction sets and so on. So he dug out like an old Intel MacBook he had somewhere to have better odds to come up with changes which also proved beneficial on the official environment.
As I'm listening to this, did you thought that like disabling a garbage collector would be crazy? for production code before you had this challenge, and now you think it's like more understandable? Did it change like some views when it comes to, because after I'm listening, what you are saying is like, yeah, if it's a short-lived task and you just like have the objects there not collected, like who does really care, right?
So I had heard about it before. So I think it's actually common in like high frequency trading and so on. So what they do there is they, try to avoid or don't do any allocations in the steady state of the application, and then they keep it running for a day, and it doesn't need to do any garbage collection. And then they, or maybe just there's so low allocations, and if they start a process with enough memory, it is enough to keep running for an entire day, and then they would kill it off after the day and like restart it. So I had heard about it before. I personally haven't done it before, but yeah, I guess I would. In particular for CLI tools, I guess I would
nothing crazy, right?
An option. Yeah, totally.
We're at that point in our episode that I have to ask everybody to like and subscribe.
Oh yes, of course. Like and subscribe.
Like and subscribe. We appreciate that. More followers we have, the easier it is to make these things. And I should also mention that we are very grateful for our Patreons that supports us, and our partners who are 3FS, Kaldi, and Human Frog. These are like web or tech-related companies in Slovenia, and they support us and means a lot. So thank everybody for the support, and make it for also hosting us. Okay, that's a PR part.
Right.
Super important to be
super
sustainable.
Important. Do you want to talk more perhaps about these 2 seconds? Because otherwise I want to move more towards a few other things.
Right. No, I think we got it covered mostly. Actually, there's one thing which I really like. This was my most favorite thing, I think. So in Thomas Wörtinger's implementation, there's an interesting detail. So you see essentially his inner processing loop. He has it like duplicated. It's like there in the source code like 3 times. So he has scanner objects which process different lines of the file. And he has the same loop with different scanners like 3 times. And so you look at his code and it's written there, and you would say it's like sequentially executed. The thing is, what happens, the compiler figures there's no data dependency between those different chunks. So and as CPUs have like multiple execution units, it actually gets executed in parallel. It runs concurrently. So you look at the code, it's written sequentially, but it actually gets executed concurrently. So it saves time. And how he arrived at 3. So it was like heuristically. So he tried it with 2 copies of the loop, with 4 copies of the loop. 3 was the fastest. So this, I had no idea about this. I found it super interesting. And of course, now this also gets into this question like, how maintainable is this code, right? Because imagine like the new guy comes onto the team, you see, there's like the same code like 3 times, let me clean it up, I want to like refactor it, make 1 loop, and boom, your optimization is away, right? So I guess you would want to put a comment there.
Perhaps a few words about like the top guys. My understanding is that the top solution, it's not written by one guy. I think 3.
They teamed up, yes, exactly.
It's a team effort, and these are guys that are actually working on GraalVM with Oracle Labs.
Right.
Is that correct?
Yeah.
Do you know the guys, or
yes, I knew Thomas before. We had met before.
They scare you a bit? Like
Say again?
They are scary guys.
No, I don't know. I think they are nice guys. And actually, this was exactly also in the spirit of the challenge to learn and inspire each other. So at some point, Thomas saw an interesting optimization in the solution from Mary Kitty. I forgot his actual name, but he goes as Mary Kitty online.
Okay.
So he had a very nice trick, and so Thomas incorporated that, and then they said, okay, let's team up and make it official, which then proved to be a problem for my little certificates at the end, because I gave a PDF to everybody with their time. So I learned how to do mail merge and create individual PDFs for 160 people.
But they're listed on 1 page. Okay.
Yeah. Yes, exactly. And the problem was, so they had like three names. So for them, my template wouldn't fit, and I had like to do like a bespoke one just for them.
Do you think that like these the side effects of this challenge, like we did some challenge 2 years ago, much smaller, but and the challenge there was, I'm gonna post link below as well, but that challenge was so intrigued to some people. We didn't limit languages, So one of the guys decided to write his own programming language.
Oh wow!
So
okay.
yeah, Janko, if you're listening, cheers. But the side effect was he learned that he can make his language better because of
nice.
trying to understand these challenges, kind of like solve problems in his implementation,
Right.
and he improved. Like, do you think that something similar might happen from this challenge, or
So
are lessons like that?
Right. So I don't think anybody invented their own programming language, but definitely people told me many times, yes, that they learned so much, about Java, learned new things, and also it's definitely helped to debunk this misconception like Java is slow. So many people made that realization. Also for other ecosystems, right? So people maybe not as familiar with Java as we are, they also learned, oh, actually there is something going on. It has like all those new APIs. It's really optimized, really competitive. So I think people took a lot from it, yes.
Is there any traction from academia? I know that might sound silly, but will there be like academic papers on 1 billion?
I have not seen any academic paper yet. Maybe, yeah.
Yeah, to come.
Yeah.
Did you also, you made the decision this is going to be a Java challenge, and it's for practical reasons,
yes,
I guess,
absolutely.
imagine. But if you go to 1brc.dev, it's a web page. I don't think you created it.
No, I did not. It's very interesting.
Yeah, but that one also has collection of links to other programming languages, so you can see the solution in C, Python, all these different languages. Did you have a peek into these solutions as well?
Yes, briefly. So what we do have, why was it Java only? So yes, first of all, for practical reasons, I just felt like, that's what I'm most familiar with, and if I need to learn how to install like Rust tool chains or how to compile with C or whatever, it would just take so much more time, and I wanted to limit it a little bit. So that was the one reason. The other reason is, I wanted to help and promote Java also. And that's why I limited to Java. But then we actually, all this happens in a GitHub repo, like my name Gunnar Morling and then 1brc, that's the repo. And we have a GitHub discussion there, which is called Show and Tell. And people are very much invited to share their links to their non-Java implementations. And this also got really huge. So there's 60, 70 threads of discussions there with other implementations like Rust and .NET and C and even COBOL and, all kinds of languages. Some of them I hadn't heard about even before. Then other tools like Org, on the command line, but then also databases, Postgres, Apache Pinot, Snowflake. So people, did it with all kinds of tools and languages. So I kept an eye on it. I enjoyed reading the blog posts, but I couldn't run them on my environment because of the time reasons.
I guess we were more like at the end of these kind of things.
Okay, yeah.
We will go swimming later on. So that's
nice.
awesome. Okay, I guess before we talk more about prize, so I guess there was a prize. At least that's my understanding of Twitter threads or whatever.
The most important thing in life.
The most important thing in life is, so obviously the prize is you're the top dog in the industry, I guess.
Right. So the prize is learning something new and being part of it. But yes, so initially, so this was like really, my own private effort initially, at least. And so I said, okay, I will pay for a t-shirt for the winner. I will pay for a t-shirt out of my own pocket. That's what I, decided to do. And then, it really took off, and I felt, okay, maybe we want to do something more. And then I spoke to my employer, Decodable, and they were happy not only to fund the evaluation machine, but also I have a company credit card, so I just can pay for some prizes. Yeah. So what I did in the end is I did t-shirts for the top 3. And coffee mugs for the top 20, and I sent it to like South Korea, Taiwan, Croatia. Actually, I was in Zagreb, and US, and so like Brazil, like all over the world. So this was my biggest challenge, like shipping this stuff to people all over the world.
Beautiful. So at this point, thanks for Decodable for actually supporting you on this.
Thank you so much, yes.
I guess. If people have ideas for next year,
absolutely, yes,
they should contact you on Twitter.
Right. Yes, they can contact me on Twitter or send me an email to Gunnar at decodable.co. people asked what would be the challenge next year. There was one guy who said, next year, next January, I will take a week off, so I have the entire time to focus on my implementation. I was like, oh, let's see whether we actually want to do it. So I'm still recovering from this year.
Absolutely,
but I think, by next January, if there's a good idea, as we mentioned, it needs to have the right balance between like easy to explain and providing lots of potential. If we have that, if a community comes together, if it's automated, because frankly speaking, I don't want to run all the stuff manually again on this machine, so it would have to be automated with GitHub Actions, I suppose. Like people could like really self-certify, and it would be like a GitHub Actions runner on that machine. If we have all that and people help doing that, I would definitely be up for doing it again.
You have any more questions, Andraž? Otherwise, I'm gonna slowly.
No, I think that was an awesome conversation.
Very, very nice. Yes.
I would like to perhaps wrap up with like less kind of a big question, or what are the lessons that are like not technical that you got out of this?
Right. First of all, never underestimate how much people would do to win this kind of thing. So this definitely, I did not expect this, like people would spend an entire month on doing that. Then, yes, people will take advantage of whatever they can. So they will optimize for the key set. They will, bend all the rules. There was stuff which we didn't even talk about, like unmapping the file. So they will do all kinds of stuff. So I did, did not expect that. But still, that's all good and fun. And then, of course, yes, I mean, I guess I was hoping to see it, but it also definitely happened, like how the community comes together, not only to, participate and take something out of it, but also to help and organize it and help and run it. And this was just so great to see, because at some point I was just overwhelmed, and I felt, oh man, it's so much. I spent like 12 hours a day trying to be on top of stuff, and people helped, and, this only made it possible. And I guess the last thing is, it was a bit of a viral thing, right? It really blew up. And what I also found very interesting, so like how you lose control over the narrative and what happens, right? Because people will take it and make something out of it like they want. And, at some point there was like a bit of a fight between like Java and other languages. And I didn't really want it to be like that. But at some point, you're not like fully in control. You're just like participating.
It feels like
in that
modern big open source community kind of a thing, where a lot of problems kind of here.
Right, and it can be a bit scary, right?
It can be a bit scary.
Because it just, stuff happens, and you try to navigate it as good as you can. So this also was definitely very interesting to observe.
Okay, I guess any last words from you, Andraž?
I would invite our community to join us on Discord and share the attempts or the solutions. That would be awesome, like to see what we can come up with. Definitely.
From my side, I invite you to follow Gunnar on Twitter. It's a stream of very useful information also from Flink and DCD. And so you should follow him. And thank you from bottom of my heart for taking the time and taking us through this challenge. And I'm really looking forward to what you'll come up next year.
Okay, awesome. Yeah, thank you so much for having me. This was great. I really enjoyed the conversation. This was really fun. Thank you.
Thank you.
Bye.
That's it. Have a nice day. Bye.